Yo, what up? Today we're gonna discuss the most important lines in Unity game development. These are used so much, it is really worthwhile to know these lines. However, this video is really geared towards beginners and intermediates, so if you are advanced, maybe skip this video and you can leave in the comments below some of your lines that you think are the most useful. This is what we're gonna discuss. There are timestamps below and I'll link the PDF with a summary of all this in the description. And let's start right away with input. All they need to do to access any key on your keyboard is write input.getKey and in parentheses keycode dot, for example, A. If we add an if statement right before, you can now run any code inside this if statement only if you have the A key pressed. Put that in the update method and every frame you press the A key, this method will run. Honorable mentions are the input.getMouse button, 0 for the left mouse button and 1 for the right mouse button, and input.getAxisRaw in parentheses horizontal will give you either -1, 0 or 1 depending on whether you pressed left or right arrow or the A or D key. We can store this in an integer and use it to handle movement in the next section. Rigidbody. If you want your character to be affected by a physics, then use the Rigidbody component, just slap that onto your game object and your game object now has gravity. Don't forget to attach a collider to your game object because otherwise it will fall through the floor. I recommend you to freeze your rotations on your game object, so in 2D you would freeze the Z-axis and I would freeze all 3 of the rotations in 3D. This way your player characters don't fall over and in 3D you will handle your Y rotation anyway using the transform component. Finally, check interpolate to smooth out certain physics behaviors. This recently smoothed out my character and made it stop shaking. And for collision detection, use continuous to calculate detections in between frames. For example, my player was able to perform a dash, and if I didn't check this, he would sometimes dash through the wall. Continuous predicts the movement of your game object, and hence, for example, your player won't get stuck in the wall if he collides with it in between frames. So let's use the Rigidbody component to move our player. Let's make a variable called RB. We assign that in the start method, and we can now change the movement of our player using the RB.velocity method. This method wants to have a vector 2 or vector 3 depending on whether we are in 2D or 3D. So if we want to make our player just move left and right for now, then the Y value doesn't matter. So for our Y value, let's pass in the rigidbody.velocity.y. If we were to put in 0, then we would not be able to fall anymore. But because our Y is now equal to whatever the Rigidbody says our Y should be, we can still fall using gravity. So let's use that for our Y and let's only affect the X. Remember from before, with input.getAxisRaw horizontal, we can check if the player presses left or right because it will return -1 or 1 or 0 if we don't press anything. Hence, we can simply set the X of our movement vector be equal to our input X. And let's multiply that by a serialized float, which we'll call speed. We want to put all of that inside the fixed update method because that's where we calculate physics. Let's not forget to type in a speed value and our player can move left and right. Isn't that awesome? Here's another cool method in the Rigidbody class. It's called addForce. For this we write rigidbody.addForce and in parentheses it takes in a vector 2 and a force mode. We can add an impulse, which is great for jumping because the player is being right away pushed up, or you can just add a force which will continuously apply a force to an object. For our jump method, let's use the impulse. So we write force mode and because we're in 2D, we add 2D and let's add .impulse. And since we're jumping, we use a vector .up. Let's create another serialized float for our jump force and multiply that as well to a vector. Let's put that into an if statement because we don't want the player to jump all the time and use our input.getKeyDown spacebar to only apply this force once if the space button is being pressed down. Alright, our player can move, we know how to handle input, so now let's make sure that the player cannot jump all the time with a very cool method which is called OnTriggerEnter. You can use OnTriggerEnter 2D for 2D games, which is what we're gonna use right now, but OnTriggerEnter is what it's used for 3D games. For this you need a collider attached to your game object. Your game object also needs to have a Rigidbody, which we already have, and we need our collider be set to trigger. Hence the collider will not collide with anything, it will only trigger. And it will trigger whatever is written within this line of code. So let's make sure that our ground is tagged as ground, and inside our collision detection, let's add an if statement to check if what we collided with, so our collision dot tag, and if the thing that we collided with has the tag ground, then we want our player to be grounded. and only then is he able to jump. So let's add the isGrounded rule to our jump conditional statement, so we can only jump if we are grounded. And let's add this fancy ass OnTriggerExit2D function. So if our trigger exits the ground, then we set isGrounded equal to false. And now we can only jump if our player touches the floor, and we do that with the OnTriggerEnter. Instantiate. With this we can spawn in a game object. Super cool, super useful, and let's make it super easy by creating a fireball game object. Look at this sexy ass fireball, and let's attach a script to it which just says every frame he will move to the right. Let's drag that into our assets, and we have successfully made a fireball prefab. Okay, we now want to spawn this fireball prefab if our player presses the fireball hotkey, which is of course the left mouse button. We're gonna write instantiate, and instantiate takes in a game object that we want to spawn, so our fireball, a position and a rotation. So let's make a game object variable, which we call fireball, and let's serialize it. And let's also create a transform for the position of where we want to spawn the fireball. In Unity, I'm just gonna drag and drop my fireball prefab into our fireball game object variable. And I'm gonna create a child object to my player, which is gonna be exactly where I want our fireball to spawn. I'm gonna drag and drop that into our fireball position variable. We can now put both of those into our instantiate function, and by simply stating quaternion.identity for our rotation, it will just spawn in the fireball at its default rotation. And because we only want to run this if we press the left mouse button, we put this in an if statement, and then we put this into the update method. And now whenever we press the left mouse button, our player shoots fireballs. But we now have a huge problem. Our fireball can go through walls. Luckily, we can use this handsome method to destroy our fireball at any given point. Let's use our OnTriggerEnter 2D method, attach a circular trigger collider to our fireball, and we need to also make sure that a Rigidbody is attached because we're using an OnTriggerEnter method. And because this is a fireball, we don't want it to be affected by gravity. It should only be affected by what we write in the script, and hence we set it to kinematic. And now let's again add an if statement and compare tag. If other is the ground, then we want to destroy our fireball. Write game object if you want to destroy the game object that your script is attached to, or you can create a variable of another game object and actually destroy that if you ever want to, and pass in that one in your destroy method. You can also add a time, and then the game object will be destroyed after this time interval. Let's not use that for our fireball because that doesn't make sense. Time. What a powerful ability to wield. You probably kind of know what this is, but time.deltaTime and time.fixedDeltaTime are very useful. They measure the time it takes between two frames. So for example, on a better PC, our character might run faster than it would on a slower PC. That is because a slower PC might have less frames. And look at this. Every frame we are affecting our Rigidbody vector. So obviously, if there are more frames, then our character will be affected more by our input and will move faster. We can work around that by multiplying by time.fixedDeltaTime because we are in the fixed update method. Use time.deltaTime if you're in the update method. And now the size of our vector changes by the amount of time that has been passed since the last frame. This might sound a little bit complicated. So let's say we have 10 seconds per frame, which is 0.1. And then on another PC, we have 100 frames, meaning our vector will be multiplied by 0.01. We have 10 times the vectors that we're gonna apply in the 100 frame example, but we have 10 times the size of those in our 10 frame example. So if we multiply our vector by this decimal number, we are now equalizing, but as a side effect, you might need to adjust the speed value of your character because we are now multiplying by a very small decimal. Here's another cool one, which is the Invoke, with which we can run any method with a certain delay. Here's a simple way how I created a player dash. So I first created a vector2 to keep the y of my player constant, because I don't want him to lose height while he's dashing, but the x value can change to whatever the Rigidbody wants it to change. I then apply this every frame in which the player is dashing, and now let's actually make the player dash by using the Rigidbody.addForce, and I want the dash to behave like an impulse as well. So I'm gonna add the force mode 2D.impulse at the end, and because we're dashing to the side, I'm gonna add the vector.right, and I'm gonna multiply by a dash force, which again I'm gonna serialize and I can set in the editor. For now, this will only make the character dash to the right, but we're gonna fix that in just a sec. Remember, we're discussing how the invoke method works. So in our update method, we're gonna create an if statement which checks on whether we press the right mouse button this time. And if we do, then we set a bool is dashing to true. Obviously, we need to create a bool for that. In this one frame where we press the mouse button, our bool will be set to true. And we want it to be set to false after, let's say, 0.2 seconds. So let's create another method, and this method is just to set our dash to false again. We're gonna invoke this method after 0.2 seconds. And in our dash function, we're gonna state an if statement that we only perform this dash if our dash bool is equal to true. Let's put that into the fixed update method because that's where we wanna handle movement. And now whenever we click the mouse button, we're gonna set our is dashing bool to true. We're gonna perform the dash method, and after 0.5 seconds, we're gonna run the other method which sets our dash bool to false again, and we will stop running the dash method. With the code that we have so far, our player does not flip. He actually walks backwards all the time. There's a very simple fix to this, because remember, we are getting our horizontal input from our player, so we always know what he's pressing at the moment. So inside the update method, we can simply ask for whether the input x is bigger than 0. That means our player is facing the right direction. But if our input is smaller than 0, so the player is pressing to the left, we can set the x value of our scale to -1. The x value of our scale is going to be positive if we don't want our character to be flipped, but if we want him to be flipped, we just need to multiply this value by -1. My character scale is set to 1.2, so I'm actually going to set this to -1.2, and if I don't want him to be flipped, I'm going to set it to just 1.2. The transform.scale is a vector 3, so in our script we can create a new vector 3, call it scale, and have it be equal to our transform.local scale. This gets the scale of our game object. Now let's flip the x of our scale and then set the scale of our game object to our modified scaled vector. Let's copy paste this for if our player presses to the right, and let's take out the minus, and we now have a player character that actually flips on the x whenever we press the right inputs. We can now pass in our transform.scale.x into our dash, and with this our player also dashes in the right direction. Scene management. If you want your player to load into the next level or to reload the level because he died, then you can use SceneManager.loadScene to load any scene that you have in your build index. If a scene is not in your scene index, just drag and drop your scene into the scene index. Look at these numbers here, by the way. They indicate the build index of each scene. So whenever you want to load a scene, inside parentheses, you have to pass in the build index of that scene. Or you can pass in the name of that scene. But this has to be the exact name of the scene. Important to note, you have to use the Unity Engine Scene Management namespace at the top of your script. Otherwise, your script will not know what to do with this line of code. And if you want to load the current scene where you're in right now, and you don't always want to pass in a number, you can load the active scene by writing SceneManager.getActiveScene.buildIndex. This will get the build index of the active scene that you're in, and hence you will reload your current scene. Audio, the most underrated thing in game development. An audio source is a very simple way to add audio to your game. You can just add an audio source component to a music game object in your scene and drag and drop an audio file, play on awake and loop, and now your music will be played all the time in the background. Pretty annoying. There's one very simple but nice method in the audio source class, which is audiosource.play. This will play the audio clip that you put into your audio source component. So let's say we have this beautiful zombie enemy and we want him to make a zombie sound every 5 seconds. So we're gonna create a zombie script on our zombie, and then let's also add the audio source component. We're gonna drag in our zombie sound, and this time we don't want it to play on awake, and we don't want it to loop. And in our script, let's first create a variable audio source called zombie sound, and in the start function we get the audio source component. Now we make the zombie sound play by simply typing zombie sound.play. But we want our zombie to be making the sound every 5 seconds and not only at the start. Let's create a serialized float, which will be our zombie sound interval every 5 seconds. And then let's create another float, which is called zombie sound now. By default, this variable is gonna be 0. And if time.time is bigger than zombie sound now, and at the start this is gonna be true, and in our if statement we're gonna play our zombie sound, and right afterwards we're gonna set our zombie sound now variable to time.time plus our zombie sound interval. So let's say our time.time is 0. That means it's equal to our zombie sound now. We're gonna play the zombie sound, and then we're gonna set our zombie sound now to time.time, which right now is 0, plus our zombie sound interval, which is gonna be 5 seconds. Then our if statement will be false, because our zombie sound now variable is gonna be at 5. The sound will not be played until time.time reaches also 5, so after 5 seconds, this is gonna be true again. We're gonna play the zombie sound, and right after we're gonna set the zombie sound now variable again to time.time, which is 5, plus the zombie sound interval, also 5. Now this variable is 10, and our if statement is gonna be wrong again until time.time has passed another 5 seconds and is also at 10. With this, our zombie will make a zombie sound every 5 seconds. The animator class I am not gonna discuss in this video because there's a lot that you do inside the editor, but I have one last caveat which might sound annoying to a beginner, but any intermediate and above knows that this line of code is a godsend because it really helps you to debug any bug. Debug.Log allows you to write a line in the console. Really use this a lot whenever you're having bugs. If you're unsure whether an if statement is not being checked, just write a debug.log just to make sure that the method is actually being executed. It's sometimes annoying as a beginner, you're not used to writing code that fast, but you're gonna get used to it real quick, and it really helps you to solve bugs. Remember, I only have been programming for about 5 months now, so I'm not that different to you if you're a beginner or intermediate as well. So let me know in the comments how far you are in your game development journey, and here's a video on how I first joined my first game jam. It was very intense, but I think it's a fun one. Here's my last video, and just have a look at this awesome subscribe button here. Wow. Thank you so much for watching, and thank you so much for all of your support, and peace.